lot easier than the way I was doing it yesterday.
Boy.
Mm-hmm. The pegs aren't tall, right?
Oh, no wonder.
I missed.
Well, you want to do the other side,
Oh, okay.
right? But that is an excellent reproduction of the example that they gave.
Okay.
Like this.
What's this one here? Negative 4. Or no, that's positive 4. That's it. So it's this side length?
Yeah,
So what's this side length? With spaces in between. And this one?
6.
Yeah, so what's the scale factor here?
0.5.
Right. What if we wanted to compare this side to this side? How would you know what length this is? Huh?
It's one.
Oh, you mean from this peg to this peg? And here we've jumped 2 pegs. True. But how else could you find that distance? Did you goof now?
How to find what?
So how did you find this line from here to here?
Well, you can do the distance formula, or you can count right to the right to find this up.
Yeah, you can. Distance formula would give you the distance between the 2 points. The rise over run, though, that's what you used. You went 1, right? You went over 1 and you went up 2. Here we went over 1 and 2, and we did it twice.
There's a rhombus.
Is it a rhombus?
No. I don't know the name of it, but it's only trapezoid.
This isn't a trapezoid.
But it can be.
But what does a trapezoid mean? It has 2 sides that are parallel. Ours here that you've got constructed, how many sides are parallel?
5.
Actually, now it's a trapezoid. Okay, go ahead and continue answering the questions. Moving on to, you're going to actually build pentagons. Okay, yeah. Hello. So what did you guys find? It's 2 to go from which polygon to which, to get from the smaller one to the bigger one. What is the scale factor to go from this one to that one?
Divided by 2 or multiplied times 0.5.
Right. When we talk about scale factor, much like that sign indicates, we want to multiply. So what's the length of this side?
3.
What's the length of this side?
6.
Okay, so that's how you got 2, right? How could you confirm it using these sides?
2 and 4.
Is this the length of 2?
Yep. Oh no, you can't prove it.
You can. What could you use?
There.
Oh.
No.
How did you find the length of the diagonal? You could. If we
But we can assume it is.
we're mathematicians, we don't want to. Okay, we assume all the time. No, but we can use the Pythagorean theorem. Where's the right triangle that we could use?
Right there, in the middle.
Yeah, we draw this line right here. We have a right triangle. What's this side?
4.
4. And what's this side?
3.
It's 2.
Oh, 2.
And so, by the Pythagorean theorem, what's this length? It'll be.
4.
So this is 4. Spread it. Then we add this. Right? write it down. We don't want to get lost. Yeah.
So before, no wait, yeah, 4 is equal to 20, and that, right?
Right?
And 2, 10, then
How'd you find? You've got to.
There are many pencils.
This has a square root over it as well, right?
I just happened to find
Right. That's
99.
square root of 2 times the square root of 10 is a square root of 10.
Plus, I
What else can you factor out of this?
5 and 6.
exactly like
Yeah.
that.
2 and
Have you known me to be like, we barely met.
2? No, we didn't.
Yep.
Yes.
And the square root of 2 times the square root of 2
I'm looking at 4.
is the square root of 4.
I'll sue you for like, this pencil has all,
Square root of 4
well, it
is.
has like sisters who put it off as mine.
Oh.
I have a receipt when I bought it.
No. Square root of 4 is, we don't need the radical anymore.
Oh, yeah.
It's just 2. Cool.
There you go.
So the side length here is
It's just
2 times the square root of 5.
who other
What do you think this is going to be?
else has an E in
If
their name?
this is 2 times the square root of 5, what do you think this side length is going to be?
Added with an N.
And Emily, we found, using the Pythagorean theorem, that this side length is 2 times the square root of 5. What do you think this side length is going to be? You're close. This is 2 times the square root of 5. This is going to be our scale factor.
From this side.
Yeah, so this is going to be the square root of 5. Oh, you did it again.
So
But,
it's 2 something.
well, this is the square root of 5.
It's like 1.9.
We can leave it at the square root of 5. That's fine. We call the distance the square root of 5. You see, you went from the square root of 5 to 2 times the square root of 5. It fit our scale factor, right? Yeah. Okay. You guys, fill it out and move on to the next one. You guys have the scale factor yet for our next set? Number 3, we're working on number 3. The other 2 sides. Okay, so we're working on triangles the first side, right? Did we ask that question later for the other? Yeah. So you guys have got these parallelograms going, right? Did you find a scale factor for those? What's the length of this side? Okay, so the space is in between. 3. Yeah. And what's this side over here? 6. So what's our scale? Scale factor? 2. Alright. And how would we find this length? How would I find this length? Formula. Because we have these coordinates, right? Very good. How else can you find them? Well, we want to confirm it, right? If we find these 2, we want to find that they have the same scale factor as these 2. The same as these 2. So how could you find this one? You can use the distance. That will work perfectly. Slope. Why don't you use the distance function and come up with a length for this and a length for this and confirm what our scale factor is. Because in the end, what do we want it to be? We want it to be 2, right? Because that's what we found for the first one. So if you have a scale length of 2, right? And it took it made our parallelogram from side from 3 to 6. It asks if you have a third parallelogram and its longest side is 12. What's a new scale factor? Let's say it was 12 and we had this original 1, 2, 3, 4, right? So it asks, what would the length of the other side be? Okay? So when you, with 4, and with this side length, you'll be able to find this side for the third parallelogram, right? All right. I'll take that if you guys have any questions. Hi, do you understand? What do you mean?
Oh, yeah, right?
How's it going? That's good. Which number are you guys on?
It was in honor of what you guys
Doing the parallelograms?
It was tight at the end. Tight?
See you guys. Not quite. You got the first one.